Bismillahirrahmanirrahim, guys. Assalamu alaikum. Mr. Atiq once again is from the science department. We have week 13. Little a bit, you can say, a small lesson regarding spectrum, electromagnetic spectrum. Look what electromagnetic spectrum. The same chapter 20, section 4. Section 4. It will be like this is the end up. It will be ended up, okay, in this lesson. The pages we are going to cover is they ranges from 419 to 421. The electromagnetic spectrum. Look at the electromagnetic spectrum ranges from very long radio waves to very short wavelength gamma waves. Look at ranges from what? From very long radio waves to very short wavelength gamma rays or waves. The electromagnetic spectrum has a wide variety of applications and characteristics that cover a broad range of wavelengths and frequencies. I have a chart. I downloaded a chart from a source, and I will display in the last slide for you guys. Understand all the electromagnetic spectrum. Okay, we have range. Look at the electromagnetic waves are typically described by any of the following three physical properties of matter. Three physical properties. Number one, the frequency denoted by F. And then again the wavelength denoted by lambda, and photon energy denoted by E. Okay. The frequency denoted by F, the wavelength denoted by lambda, and photon energy denoted by E. Frequencies observed in astronomy range from 2.4 raised 10 to the powers 23. Frequencies observed in astronomy range from 2.4 raised 10 to the powers 23. Photon energy is directly proportional to the wave frequency. Photon energy is directly proportional to the wave frequency. So gamma ray photons have the highest, around a billion electron volts. That's why it has the highest. Okay, you need to learn the frequency, wavelength, and photons. Okay. As far as the electromagnetic spectrum or electromagnetic wave spectrum are concerned, okay. In the coming slide, we have all spectrum waves are given there to study. Okay, we have another slide. This is the main area of concern, and it must be. Look at, I downloaded this from a source. Electromagnetic radiation interaction with matters. Look at how it reacts with matter, how it interacts with matter. Region of the spectrum, these are the regions. Look at radio, microwave, near infrared, visible, ultraviolet, X-rays, gamma rays, high energy gamma rays. Okay, and these are what? Main interaction with matter. For the first, radio, look at collective oscillations of charge carriers in bulk materials, plasma oscillation. Look at an example would be the oscillatory travels of the electrons in an antenna. Radio waves, okay, like that. For it been used for the transmission, okay, from the transmitter to the receiver, okay, for capturing all the informations and all the waves. The antenna been used there. Microwave through far infrared. Remember, Z involved in the microwave. All I studied by myself microwave engineering. There we need to find like the X and Y, and Z was the 3D object there. So the plasma oscillations, molecule rotations are there. So it gives us the three-dimensional. If you are going to study the 3D, okay, for the X, Y, and Z, so you will see the rotation there. So you can see the molecular rotation there. Near infrared, molecular vibration, plasma oscillation in metals only. Okay, just molecular vibration. Visible light, molecular electrons excitation, including pigment molecules found in the human retina, like in the eye. Plasma oscillations in metals only. Remember, plasma oscillations in the metals only. For the ultraviolet or UV, excitation of molecular and atomic valence electrons, including ejection of the electrons. Photoelectric effect. Photo, look at photo, then electric, and then effect. X-rays, excitation and ejection of core atomic electrons. Excitation and ejection of core atomic electrons. Compton scattering, look at, for low atomic numbers. X-rays, okay. It is used by by the way in hospitals as well. Gamma rays, energetic ejection of core electrons in heavy elements. Energetic ejection of core electrons. Gamma rays being used for that thing, okay. Compton scattering for all atomic numbers. Excitation of atomic nuclei, including dissociation of nuclei. High energy gamma rays. Creation of particle antiparticles pair. At very high energy, a single photon can create a shower of high energy particles and antiparticles upon interaction with matter. Now it states clearly, look at high state or high energy state gamma rays. Look at the creation of particles antiparticle pair. Okay, the emission of electrons in the form of radiations. The people, they are studying there. Microwave, visible, X-ray, gamma. And high energy state gamma rays are responsible for the attempt to see the molecular pure structure. Got the idea? So today's lesson kindly cover up the section 4 electromagnetic spectrum. This is the very you can say like important lesson for you guys, and I do hope so. Okay, my suggestion for you guys is what, like, to attempt your online exam well. Okay, don't be missed that thing. Fi amanillah.